Welcome everyone. In today's video I'd like to share with you a library I put together which I call the Tiger library. It's primarily designed for process applications. So whether those applications are in oil and gas or water, wastewater, or perhaps food and beverage, using this library will help the developer speed up the process of designing and putting together the application required. So I utilized the Rockwell platform for this library, so you can basically use FactoryTalk View SE version 8 and later from the HMI standpoint, and then from the controller standpoint you could utilize either Control Logics or Compact Logics version 21 and later. For those that are interested, I'll be more than happy to share a copy with you guys. All you need to do is just leave interested in the comment, and I will get you a copy. And for everyone, you know, your comments, what you like, don't like, suggestion, they're all welcome and indeed appreciated. So just to give you a quick idea that if you did decide to get a copy, that you will also get, you know, beside the library graphics and the blocks for the controller, you'll also get manuals, as this object has their own manuals. So just to give you a quick idea, so this is, for example, the analog input manual. So it looks something like this. So the Tiger process library analog input, and then in there is like a brief description, little diagram, and then the parameters for the specific controller you're dealing with, how to implement it in the PLC and HMI, etc. So it's fairly documented, so you could, you know, either watch the video or perhaps you know, use the manual. Either or, they're all valid options. Okay, so let's dig into the library so I can show you quickly. I don't want to bore you with too much details about the library, but just, you know, quickly show you each object and what it does and etc. So this one will be utilized with discrete alarms, so you could use it with the level switch, for example, pressure switch, etc. So as you click on it, you have its dedicated faceplate, and it consists of two tabs. So you have the home tab, which is designed for the user, and then the setting tab, which is designed for the admin or the developer. So for example, in this particular case, for the discrete alarm, you can see the status here, it's good. The other thing that you can see, if you point to that status, you will see the in alarm and the last time it has been acknowledged, and actually that time it's coming from the PLC, so the alarm is time stamped in the PLC in this case. So next one is the analog input. So for the analog input, again, the same design, the two tabs. We can see the set points for our alarms. We also have the bypass capability, the same as the discrete alarm, and you can turn it on and off, so it's all customized. You can call the trend to trend your analog, and it has the history, so the user can go back in history, and if they would like to. and then from the setting standpoint, you can set up your debounce time, your description, etc. The high highs and the low lows are not settable from the HMI, so that's just my own preferences. I don't open those even from the HMI. They have to be done through the PLC side, but if you'd like to open them up, it's you know, it's customizable. You can do that. The next object is the valve. So this object will allow you to control basically a valve that's controlled by a sound. So in here again, the description area, tag, auto manual, I can call from this button the shutdowns for that particular valve, so it shows me all the shutdowns. And I'll be covering all these objects in different video in more details to show you a little bit more about each object in a little bit detail and how to use it, but in here we're just basically scratching the surface essentially. So again, here in the settings we can set up things like whether this valve is fill open or fill close, whether it has limit switches for open and close statuses. If not, like in my case, I'm just using a simulation for simulating my feedback, so you can do that. Open and close. You have that capability to customize those buttons, whether to have them or not, etc. So the next one is the control valve. So this valve is controlled by a PID. So this is how it looks like. Again, the same design, tabs, so home and settings. So in here we can go auto, manual. Right now we're in auto. We can change the set point just by sliding this arrow in here, or we can click on this and then change the set point if we'd like to. Also, you can call the trend, and you'll be able to trend your set point, PV and out. They're all there. And then the other thing you can also do here with the PID is you can call actually the transmitter. It's part of this PID, which in this case is PIT 1010, which is this guy right here. So you can call it from the PID faceplate if you'd like to. In the settings, you can set up things like tuning parameters, control action, and whether this valve is fill open or fill close. So it's very straightforward. Next one is the motor object. So this object will allow you to control, you know, basically a pump, a fan, anything that's driven by a motor, and whether that motor is controlled by a VFD or crossline starter, you'll be able to use this object. So if we go to the setting tab, in here we can specify whether we're using a VFD or crossline. If we used, for example, a crossline for this, we can see that the VFD stuff, it's went away. Same here, if we go to the home, you know, the set point for the speed, it's gone. I don't have that anymore. And if I go back to the VFD, then I have all that stuff back. The other thing is the confirmation. So whether I want, if I click on this and I say stop, it's gonna give me, you know, are you sure you wanna do this? So just a kind of a second chance for the user before taking that action, etc. So and then the last object I want to touch on in here is the, you know, let's say you have a pump in this case, for example, that it's controlled by a PID. So in this case I'm just controlling my speed using the flow. So this is how it looks like. So it's kind of combination between the PID faceplate and the motor faceplate, kind of combined into one. So in here I can stop my motor, I can change my set point for the flow I want to run at, for example. Right now I'm in manual, so I can switch to auto and I can see the speed is modulating. From the settings stat point, you can set up the tuning, forward reverse action, confirmation, and then you have also the VFD stuff and the run feedback, whether it exists or not. So in my case I don't have a physical one, so I'm just using a simulation here that it's built in already to simulate that my pump is running at 60 hertz right now. So that's it for me, folks. I hope you enjoyed the video. Again, if you have comments, suggestion, what you like, don't like, please share them all. They're all welcome and appreciated.